Welcome to EDU World Space.
Here is the formula to find the E heat exchange from the system. So Q equals Ms delta T. Considering the mass of ice at negative 20 degrees Celsius, while volume of water at 83 degrees Celsius is 500 ml, we can determine the mass of water. So density equals mass by volume. Substituting the value to determine the mass of water, we have 1 multiplied with 500, mass will be equal to 500 grams. We have to find out the amount of heat energy released to decrease the temperature of water from 83 degrees Celsius to 0 degrees Celsius using formula number 1. Substituting the values into that formula, we have 500 grams multiplied with 4184 multiplied with change in temperature, so final minus initial temperature. It gives me the value as negative 173,636 joules. Here we have a negative sign, that means the heat is released. We need to find out the heat required to increase the temperature at negative 20 degrees Celsius to 0 degrees Celsius. So again using the formula Ms delta T, we substitute the values. So 20 grams multiplied with 2.03 multiplied with 0 minus 20 degrees Celsius initial temperature. So heat required will be 812 joules. Further, we need to determine the amount of heat required to melt the ice. So it will be mass of ice divided by LF multiplied with LF. So giving us 20 grams for the mass multiplied with 334. Amount of heat required to melt the ice will be 6680 joules. So we have the total amount of heat required to change ice to water at 0 degrees Celsius over. We also have the value of Q1 equal greater than Q2. So total Q will be equal to Q1 minus Q2, that is 173636 minus 7492 equals 166144 joules. Using the same formula as conservation of energy, Q is equal to Ms delta T. 166144 equals 520 multiplied with 4.184 multiplied with temperature minus 0 degrees Celsius. This gives me the value of temperature equals 76.36 degree Celsius. This is the final temperature of the mixture.